I'm at the butt end of the tree, as it were. I come from a farming background. My father was a practical farmer, and roughly 50 years ago, when they used to spread muck, they used to tip it out with big trailers in the field, making a big mess, push it around with a drot and then try and plough it in. Those days are now gone, thank goodness, and we try to do things a little bit more professionally now. I've been at Bedfordia for 22 years. In that time there's been many changes. When I started there, we had a 400 cow dairy herd that was on deep litter, so they were mucked out every 3 to 4 weeks to keep the cell counts down, and we were rearing roughly about 15,000 pigs that were contract finished in Lincolnshire. We had lots of muck, straw. It was always an inconvenience, and basically it was a waste disposal exercise. At that time we had a 6-year rotation of wheat, beans or peas, wheat, barley, and then into oilseed rape. In 2003 the dairy folded, basically on the back of economics, and in 2004 it was a decision that was taken to finish the pigs actually on the holding, and a new finishing unit was built. On the back of that it was decided to go into AD using the slurry from the finishing unit, and that opened in 2005, and we then opened a second one operating on food waste only in 2010. So thence started the system of having to manage a phenomenal amount of very useful liquid fertilizer. The initial biogas plants were Welltec, so that was German technology that was designed to actually handle maize and sort of arable co-products. We turned it round through a lot of research to take food waste and pig slurry. So currently we're processing roughly 90,000 tonnes of food waste, depackaging annually, and that goes through the 2 anaerobic plants. The new finishing unit has now been extended again over this photo, and there's currently 33,000 pigs finished annually out of here, and there's another 12,000 tonnes of slurry goes into the AD plant. So from the production units, we've got 2 production units, and I also have to handle another 3,000 tonne of pig muck. I try to move that pre-harvest from the storage sites on each unit. We try to use that on areas where there's naturally phosphate deficiency, and I try to do that and get it spread when we're not quite so busy, when we're on oilseed rape, so for first wheat, or when the opportunity exists where we're able to plough it down for second wheat. Additionally to that, we empty the 2 4,000 tonne slurry stores each season, so in August and also then in the following spring. The autumn digestate is largely spread by a contractor, and we've gone down a route and help him to sort of process new equipment. So there's a clay drill that goes straight into stubble, or on a secondary basis it's an Evers injector that he uses. Again, this is completely weather driven, but normally through August we're handling around about 38,000 tonnes. So that's to minimise odour, reduce volatilisation, and also maximise the opportunity of the nutrients staying within the sort of top 75 to 125 mil of the soil. Current cropping on 2,200 hectares, we grow 2 milling wheats and an oilseed rape. I'm trying to utilise the nitrogen that we have on tap to our own advantage. We're applying it to over 3/4 of our land area at the moment, and the excess digestate is applied to our neighbouring farmers free of charge. I try to get most of the digestate to our neighbours, in the autumn, because obviously getting it transported, it's far easier to get it injected into an arable crop in sort of August, September. In Lmax terms, this year, for this last harvest, roughly 35,000 kilos of nitrogen came from the autumn application, which was 11,000 tonnes on our own land. And I tried to maximise on Bedfordia's land, because we have our own irrigation system on each land mass. We put another 183,000 kilos of the spring application. This accounted for roughly 40% of our nitrogen use annually for last year. And we grew roughly 14,000 tonnes of milling wheat to full spec, and roughly 2,600 tonnes of oilseed rape. In the spring, we use an umbilical system. I run 2 of these. They drive on RTK systems. They have tramline options that you can press. We're on 40-metre tram lines, and these are 20 metres wide. So they go in between each tram line and then up a tram line. We analyse, it's all PAS 110 at the moment. When I was operating on deployments, that was a slight headache, because I was running 32 deployments a year. And those of you in the room that have had to do that, it's quite a workload. On an average analysis this autumn, we were getting 7.5 kilos of nitrogen, 1.25 kilos of phosphate, quite high potash, 0.75 kilos of sulphur, and some magnesium. I also looked to the zinc and copper, as Jonathan alluded to earlier. For our Lmax, I allocate 50% of the total nitrogen applied off the Lmax to that crop. And for the spring application, I allow 80%. So, we regularly sample all of our mucks and slurries from Biogen, which is our sister company. They're analysing each plant once a month for PAS 110. So I get a good indication as to what each batch of digestate is going to be. So, as Jonathan alluded to, soil sampling for other nutrients, we have to identify the limitations of our soils. I try to maintain a good soil structure, like you all in this room, and as the gentleman asked earlier, soil structure is key to the utilisation of the nutrients available in the soil, and obviously the growth of the plant, so it can utilise that you apply through the growing season. The big trouble for me, or challenge for me, is balancing the nutrients that we've applied or misapplied, because we're applying up to our MVZ ruling in the autumn, and it's then that we're trying and grow crops correctly with quite a lot of nitrogen underneath them. Also, we will be mistiming nitrogen in the spring. We will be applying more than your standard 100 kilos in one hit. We'd be applying 225 to 230. We use high rates of PGR programs to try and manage the plant so that it doesn't actually end up falling over. So I use soil mineral nitrogen tests just to benchmark, and I've been doing that now for over 8 years in the same position to try and understand where that nitrogen in any given year, season on season, has moved through the profile. That gives me a good indication as to what is actually going to be available to the plant in early February to early March. As part of that management structure, I'm using Leaf Area Index as a management tool, again, just to give me an indication as to how well that plant has taken up the nitrogen that's supplied in the previous autumn. And I'm also using an end tester to actually go then benchmark within the field differences as to how much nitrogen has actually been taken up by the plant. And I'm also using a similar method of sap tests to understand what nutrients are short within the plant and what effects one nutrient has against the other. Some of our slides are quite similar. We all understand the mechanical side of our operation on farm, so we want to know what our soil types are. We all have a cultivation regime or not, and we all try to maintain the best soil structure we can. We understand our chemicals side of the equation, whether that be the actual chemistry for weed control, the chemistry for disease control, or the chemistry of nutrition. The biological is the new kid on the block, measuring soil organic matter, trying to understand what other effects that soil flora and fauna are having on the growing crop, the root systems, and the new buzzword at the moment is soil health. I call it potential output. The end tester is very useful just to give me an indication as to what is actually in the plant in terms of nitrogen. It's important to understand that it's just not nitrogen that controls yield, it is the balance and the interaction of the other micronutrients and macronutrients that actually have the biggest effect on nitrogen utilisation. Jonathan touched on manganese, sulphur, magnesium and zinc, all of which I apply as a foliar feed every time I go through with the sprayer. I spend roughly £125 a hectare on blackgrass control. I spend roughly £175 a hectare on fungicides. Our trace element bill is £20 a hectare. The LII scan index, again, is part of a management tool. The only time I use variable rate nitrogen on bedfordia is for our sort of new fall application. That's the only time that it appears to show any benefit to our overall productivity. Rainfall, as Mark alluded to, in the 2012 harvest, we actually had a very, very wet harvest period. That doesn't indicate where the rainfall occurred. As last year, we actually topped out at over a metre, when our average rainfall is around about 650 mil. The biggest indication of your nitrogen use is actually the nitrogen cycle. We want to limit the nitrous oxides, the ammonia losses. We want to maximise the plant assimilation and the lockup of any applied nitrogens that we apply as organic manures in organic matter or locked up in the clay particles. The figure of 60% utilisation is actually, that's the top end by some standards, and that equates to 40 kilos of nitrogen being applied for 23 kilos required per tonne of yield. It's a huge loss of nitrogen. So how much do we lose through leaching, ammonification, or as nitrous oxide gas? Can precision agronomy help us to manage this nitrogen use better? I rotationally plough when the opportunity exists. Last year we ploughed 95% of our second wheat. This year we ploughed only for 10%. But soil structure is key to our profitability. I also believe in good quality seed beds, attention to detail to establish a crop, both for weed competition Also, it's the evenness of the establishment of the crop, whether it's wheat, barley, rape, whatever. I believe attention to detail is paramount. The end result is obviously yield. That's our goal. At the moment, we're only achieving roughly 50% of the genetic potential in most instances. We seem to have hit a plateau over this last 15 or 20 years. And occasionally it comes right, as it did in 2015 and 2016. I believe in quality wheats. Protein is the benchmark for which it's the measurement of whether I've done my nitrogen strategy right. This year I got it wrong. All our milling wheat made nearly 14% protein. I could have missed out the new fall and saved ourselves money. But we're all trying to do the best we can with the resources that we've got at our disposal. And I think at best it's down to a lot of luck as well as the weather. At the moment, when we were operating on deployments, I was limited on the amount that I could apply per hectare by the Environment Agency because they considered that the luxury potash I was putting on, which was roughly 120 to 130 kilos a year, and our indices are over 2-, they deemed that to be unacceptable, and therefore I was limited because of potash. So I was forced into the route of straw removal to try and reduce potash. At the moment, it's actually worth to us about £100,000 of our income annually, and it aids our cultivation strategy at present. Our soil organic matter we've been measuring now for 8 years is slowly increasing, not decreasing as a result of moving straw. Our yields at the moment are this. You can see that in 2016 we had our lowest yield of rape for around about 4 or 5 years. But our 1,000 grain weight was 20% below what it was the previous year. So it equated in reality near to our 5-year average. Our wheat yields, again, are variable, with 14 and 15 being, thank you very much. We made more money in 2012 with the lowest yield on record because we were able to add value through our grain plant. The vagaries of yield are something that we all strive to even out and achieve a more consistent standard. We're all having to budget both for financial reasons, and we're all trying to do the job better. I think we are not there yet. There's huge rafts of improvement to be made. Oh, that didn't come up. This was actually, I don't know why it hasn't come up. I'll try it again. Oh, there you go. That's yield data in raw form on an old airfield. You can see the crisscross where the arrow is and where the runway went out into the bottom arrow. This is the scan data, the EM38 scan data that was compiled by soil, showing the same. The yield and the scan data do bear out against one another. At the moment, we've been part of the AutoN project, and that's a protein map. That's the corresponding yield map. The one is the converse of the other. I think that at the moment we're not quite getting our nitrogen levels right because we have to vary it through the season, and from a protein point of view, this is why I'm varying nitrogen when I apply new fall. Anyway, thank you very much.